continue worksheet 15B and part C here, deflection at free end and also cantilever. Go back to the appendix B again. As you can see, only the first 3 fingers are cantilever, and for the distributed load only finger 2 are usable, and that have to apply for the full length as we show in the part B of this same worksheet 15B. So how can we do with this? It's only 4 kilonewton meter at the end. The first one is 6 kilonewton meter on the first 6 meter, and this one is only for the first 4 meter. How can we deal with that? So we need to have some transformation, some manipulation in this case, and here is what I'm showing to you how we overcome this. Yes, cantilever with the load, can I make that equivalent to the cantilever with the same length, have everything load, all the load throughout and that 4 kilonewton per meter. Of course, they are not equivalent, right? They are not equivalent for now. So let's put some dimension in here. 6 meter, 4 meter. For now, it's not equivalent yet. They are not the same. The only 4 kilonewton meter in the 4 meter. Now I put the whole 10 meter. How come it's equivalent? How can I get away of that to make it equivalent? Can I replace with that here with the distributed load with the same magnitude but going up? You see 4 kilonewton per meter. And can you see that equivalent? Of course, at the first 6 meter, there is 4 kilonewton meter going down and 4 kilonewton meter going up. Then it's 0, same as the original problem, right? And the last 4 meter, 4 kilonewton per meter. Make sense, everyone? So, as you can see, we do some manipulation to be able to apply superposition with appendix D given in here. Otherwise, we cannot do with an appendix D. Of course, if you have more fingers, then you'll be able to find out. But in this case, only finger 2 is usable, and they have to distribute it throughout of the cantilever. We have to do some manipulation in here, and that's what I do. And as you can see, have a load going down 4, load going up 4, then it should be the same in that sense, right? So with that, or if you say you have no money, in this case the 6 meter, right? And it equivalent to you receive $10 and someone get out immediately $10. So you still have nothing in the pocket. Exactly the same in this case. So with that, how can I do with equivalent, and then it become, as you can see, that problem become what? The cantilever for the whole 10 meter. And the load going down 4 kilonewton per meter plus the cantilever exactly only 4 kilonewton in the 6 meter, first 6 meter. So that go back to the problem we did in B, right? Go back to the problem we did in B. So what does that mean here? We can equivalent another beam here for 6 meter, and then to apply the finger, and then 4 meter with something attached to 4 meter. And that similar concept we apply in B already for the first 4 kilonewton per meter. This is 6 meter, and of course that is 4 meter. And the second part here, as you can see, exactly the same, just flip the direction of the load for part B that we already did. So what does that mean here? For the total deflection of that question asked is equal to the deflection on the first free end, which is brought down that it will be here, but deflection, and that we have that one is y1, and for this one, as you can see, it will be deflect up with that load. Deflect up here. And that one first it will be y2, and then it continue to deflect for the next 4 meter, and that it become a straight line. And that additional slope, additional deflection here, we call that y3. And if we add y1, y2, y3, it will be equal to the total deflection that we have. And as you can see, similarly in the part B, that is theta for the slope, as you can see there. So with that concept, we can have y, the total deflection for the problem, equal to y1. Okay, and of course it equal to the y2, but this is the load going up, right? The load going up, so we can have that is negative y2 and negative y3 because the load up there. So from that we can apply the equation y1 for 6 meter, so 10 meter, the maximum deflection WL4 over 8EI. So that one here, you have it negative WL4 over 8EI. And that is, I call it L10, okay, L10, so that we are not confused. And then because it's positive, so we flip LW L4 for 6 meter, so we put 6 here, so it's not the same EI, and then plus, because the slope up, deflection up, so that I put positive, I change from that equation negative here to positive to reflect the fact that the 4 kilonewton meter for the cantilever 6 meter is up. W L6, keep that in mind, power 3 6 EI. And from that we can plug in the equation here. So we have negative 4, that is the load, negative 4, 10 L10, so 10 power 4 over 8 EI, I will associate out, plus W, in this case 4, L is 6 power 4, 8 plus 4 W 4 times 6 power 3 over 6, and the whole thing here we can have over E 200 10 power 6 for kilopascal, and for 10, something we did before, negative 6 for mid power 4. And from that we can find out y equal to negative 0.0461 meter, or equal to magnitude 0.461 meter going down. And that our answer, and we have completed worksheet 15B.